All right, ladies and gentlemen, this is Eric Sullivan again. We're going to be talking about packages, and in particular, we're going to talk about Numpy one more time. This time I'm going to be a little bit more specific about how Numpy is going to be useful when doing some mathematics. So I'm going to show you a couple of tools that I use fairly frequently in Numpy. So the list here is applying functions to a list, special Numpy functions for trig, logs, roots, things like that, and then a little bit of a comment on complex numbers. Even though if you're maybe in a calculus class, this isn't going to come up real often, but it will come up more frequently than not if you're in a differential equations class or a linear algebra class. So let's talk about applying functions to a list first and foremost. So let's import Numpy as NP. That is the standard nickname that everybody in the world uses for NumPy. You could give it some other nickname, but then your code would be basically unreadable to any other person who knows Python. So I'm going to define a function, just a real simple one. It's going to be a function, take in an x and return x squared plus x plus 1. Right? Whatever. It's a function. It's just a function that I'm going to, it's just the quadratic function, f of x is x to the second plus x plus 1. We're just going to apply that function to a list. So I'm going to say x is np.arrange from -3 to, we'll say 3.1 by 0.1s. Right, so this is a list. More importantly, this is a NumPy list starting at -3, ending at 3, not 3.1, and going by 0.1, or 0.1s. Right, now I can apply f to that list just by saying, hey, take the list and shove it into f. And if it's a NumPy list, it just works. It absolutely just works. I want you to compare that to if I did the range command to try and generate this list. Okay, I'm going to get issues with the range command first and foremost. So let's try the range command like this. Let's even do like the range command 0 to 3. And knock off all the parentheses. Okay, I'm getting errors all over the place. It doesn't know how to apply powers to a range. It doesn't know how to apply, it doesn't know what to do with this thing. Right, so if I do np.arrange and give it some list of numbers, I can give it a step size, then I can apply a function to everything in that list. Now, I didn't even need to be so fancy. I could, let's comment that one out, and just say x is, maybe I just wanted to evaluate this function in 10 different numbers. I could do numpy.array and do, I wanted to evaluate this function at -3, 5, 7, 9, 11, and 15. Say I wanted to do that. I do it, and it just spits it out to me. That's wonderful. To make this a little bit more clear, if I print this, so -3 went in, I got 7. 5 went in, I got 31. 7 went in, I got 57, and so on. So being able to use NumPy, use the power of NumPy, and then apply functions to lists that are NumPy lists is super handy. Okay, next thing. Special NumPy functions for trig, logs, roots, etc. So if you have NumPy lists, you're going to want to apply NumPy functions to them. So if I wanted to take the sign of a bunch of things, so I'm going to say my list is an np.array of np.pi over 2, np.pi, and 3 times np.pi over 2. So I wanted to, let's just do 0. Okay, so on the unit circle, I wanted to do 0, 90 degrees, 180 degrees, 270 degrees. Okay, that's my list. Okay, so first of all, that's the list of angles that I'm interested in. Say I wanted the sign of all of those things. I would do np.sign of my list. And it gives me my signs. 0, 1. Ooh, this is interesting. 1.2 times 10 to the -16, okay, that's 0, and -1, exactly as we expected. Okay, if I wanted to do the cosine of those things, I can do it. So 1, 0, minus 1, 0, because that's 10 to the minus 16 again. If I wanted to do the tangent, I could do it. Not a problem. Oh, now check this out. 1.6 times 10 to the positive 16, that's infinity, all right? That's humongous. And it's figuring out that, hey, tangent's having a major problem here. Okay, similarly, I can do things with logarithms and exponential. So this is something that you're going to run into fairly frequently. So let's build an array. So let's say I wanted to do 1, 2, 3, 4. That's the numbers that I wanted to apply the log function to, the natural log. I could do np.log of the thing that I just called next list, and it will take the natural log of those things. Okay, no problem. I could do the exponential np.exp of the things in that list, and it'll take e to the all the things in that list. So moral of the story is, if you have a NumPy list, if you have an array of numbers that are in NumPy, you can apply NumPy functions to them, and it works perfectly, exactly the way that we want the math to be operating on those lists. For me, I basically never use Python lists if I'm doing math. Now, the last part of this video, I'm going to talk about complex numbers. So if you're in just like a Calc 1 class, you can maybe ignore this part of this video and stop it here. If you're anything beyond maybe a Calc 1 class and you're going to run into complex numbers more often, keep watching. So complex numbers are always in the form a plus bi, right? Where I is the square root of -1. So you've run into this guy before, right? I is the square root of -1. You've run into him in algebra classes way back when. So if you want to define a number, I'll say z is equal to 1 plus 2i. Now, if I did 2i like this, it's not actually going to work. Unfortunately, but for good reason, Python uses j for the complex number. J equals square root of -1, which mathematically we know as I, right? And notice I didn't put I did, 2 times 1j, right? So if I print this, it actually knows that as a complex number. I could even say, what is the type of this thing? And it's going to say that it's complex. Just to prove to you that I'm not lying, if I did x is equal to 4 and did the type on x, it's just going to say that it's an integer. Okay? Okay, so I can do a few things in NumPy to complex numbers. I can do like, I can do the real part of this complex number, and it'll return 1. Okay, I can do the imaginary part, and it'll just return 2. I can do the angle, which you may not know anything about at the moment. But if you've done something with complex numbers, you'll actually know what the angle is. What we're talking about is the angle in the complex plane. So you can work with complex numbers in a really simple way. You can do arithmetic with complex numbers, and it'll actually do complex arithmetic in just the right way. Okay, I think I'm going to stop this video here. This was meant to give you a little bit of a deeper look at what NumPy is really good for. Most of the time, I am going to be using NumPy for my mathematical computations.